Okay, let's wrap up our unit on writing linear equations. Today we're going to get to some real data and find out how we can take some data and make a linear model. So represent the data that we have with an equation and use that equation to make predictions. And we'll perform what's known as a linear regression on our graphing calculators. I'll show you how to do that with your TI 84 graphing calculator and also on Desmos. Let's first start off by taking a look at scatter plots and what those scatter plots mean. So a scatter plot is a group of points found from two variables. So we plot the relationship between those two variables, and we take a look at what those points, what kind of trend they show. So for instance, the first one here is a positive trend because the points all seem to be forming a line going positively. This example is negative, and for this example there doesn't seem to be any correlation because the points just kind of are random. There isn't really a line for those. So take a look at these two graphs below and see which correlation they have, that positive correlation, negative correlation, or no correlation. So the first one, hours of studying compared to test scores, that one we can say is positive. Generally, the more hours you spend studying, the better your test scores are. The next one, hours of television watched compared to test scores, there seems to be a negative correlation to that one. Or to draw a line through those, it would seem that the more hours of television watched, the lower the test scores. You better study. So when you draw your trend line, the other thing to keep in mind is that about half the points should be above the line and half the points should be below. This one I didn't draw a line of best fit very well because most of the points are below the line, but you get the idea. It looks like it's negative. All right, so let's take a look at some real data. The table shows the number of active red-cocketed woodpecker clusters in a part of the DeSoto National Forest in Mississippi. We want to write an equation that models the number of active clusters as a function of the number of years since 1990. So if the year is 1992, that would make this year 2 since 1990. This would be year 3, year 4, 5, 6, 7, 8, 9, and 10. I'll explain why we're doing that in just a moment. So when we make our scatter plot, instead of using the years 1992, it would make our scale very big down here. We're just going to use 2 because that makes us for a smaller number. So why don't you pause the video, make a scatter plot of the data. For instance, 2 years since 1990, there were 22 active clusters. So put a point right about there. So finish putting all the points on, draw a line of best fit, and then we'll talk about how we can write an equation for that. Okay, so we can see the points that were plotted that represent the years versus the active clusters. And then I drew a line of best fit. I got about half the points above the line, half the points below. And I even went through a couple of the points. And then in order to write the equation, I picked out 2 points on the line. So I picked 945 because it went right through that point. And then I picked another point that it went through, 324, because my line went through one of the points that I plotted on there. And I used those 2 points to create an equation. So I found the slope, and then once I found the slope, I plugged the slope into slope-intercept form, chose one of the points to insert for x and y, and I simplified my equation, subtracted 21 halves, which is the same as 10 and a half, to get 13 and a half for my b value. So my equation ended up being y equals 7 halves x plus 13 and a half. So this equation models the situation that we have. Obviously it's not exact, but it gives us an idea that we can use to make predictions later on. And we'll do that in this example. So I'd like you to take a look, read through the example about audio cassette tapes, which maybe you've never even heard of before. They're so ancient. But take a look at years, and we're talking about the period from 94 to 2002. So years since 94 would be a way to label this. And then make your scatter plot, draw your line of best fit, and then write your equation. And then once we get that, we'll talk about how we can use that to make a prediction for 2004. So pause the video, start it when you're ready. All right, so I wanted to make mention, forgot to mention that earlier, but your equation might be a little bit different than what I got. If you ended up drawing your line a little bit differently and you chose different points, it's going to be a little bit different. It should be fairly close to what I had, but keep in mind that the line of best fit will have different equations based off of how you drew your line. So here's what the graph looks like. I chose the point 0, 350, and 675, and when I did that, I found my slope to be negative 45.8, and since I had the y-intercept, I just plugged in the slope and the y-intercept. So if you're able to do that, you can save a little bit of time. Otherwise, like we did before, use your 2 points to find slope and intercept. Now, step 4 says, let's use our equation to predict how many cassette tapes were shipped in 2004. 2004 would be 10 years since 1990, or 1994. So if we look on our graph, according to our line of best fit, it's going to be in the negatives. Exactly where, not sure because our scale disappeared. So what we can do is we can use our equation, y equals negative 45.8, and x is 10 plus 350. And if we simplify that equation, that gives us negative 458 plus 350. And when I add those two together, I get negative 108. So negative 108 is my value for y. And what does y represent? We're talking about millions of tapes shipped. Negative 108 million tapes. Now, let's take a look at that answer. Does that make sense? Well, you can't ship a negative number of tapes. So what does that mean? Well, according to the data, we weren't shipping cassette tapes anymore. That was about the time when CDs came out and cassette tapes went obsolete. So you're done sending those. So you can see that your line of best fit isn't always going to give you an answer that works perfectly because things change. They didn't always follow this pattern. Eventually they slowed up. Maybe there were a few cassette tapes being sold every once in a while, or they just stopped. We have to interpret our answers then. We can't just go blindly. All right, so now let's just mention zero of a function. A zero of a function represents when the function equals 0 or y equals 0. Because y equals 0 along the x-axis, according to plane, the 0 is also the x-intercept. So it's just another name for the x-intercept. So if we want to find the 0 of the function, we just put 0 in for the f of x, and then we solve the equation. So often when we're trying to make lines of best fit, we need to find the zeros of the function. So I would add 20 to both sides to get x by itself. And then I have 20 equal to 7.5x. And then I would divide both sides by 7.5. And then I would get about 2.6 repeating. Same thing with this equation, 0 in for f of x. 1/8 x plus 2. So I subtract 2 from both sides. And negative 2 equals 1/8 x. Multiply both sides by the reciprocal times 8. So negative 16 is my value for x. Okay. As I mentioned, these are the x-intercepts. And when we graph our equations, it's easier to find those zeros. But it's also important to be able to do that algebraically. So, now the fun stuff. Performing a linear regression can be difficult to do by hand. When you're drawing that line of best fit, it's not always exact, and then your equations can be off a little bit. So it helps to use technology to do this. And technology can do this very simply. So Let's take a look at the data, and I'm going to show you how to do this on a graphing calculator, and then I'll show you how to do this on Desmos. Alright, so if you have a TI-84 calculator or similar, you can follow along and I'll show you how it works. Otherwise, just pay attention, and I'll show you on Desmos how to do that also. So if we want to create a scatter plot, first thing we do is go to Stat, click on Edit, and Enter. And we get two lines. So if you already have information entered in there, you can just clear it out, hit Delete. I guess it's not working. So I can delete the points if I need to enter new ones. Otherwise, I just enter my values. So in the situation that we're working with, we're creating a scatter plot of women's clothing stores in the United States from 97 to 2002. So these are years since 97, so you can follow along in your directions. I enter the data. So I'm going to enter 0, 1, 2, 3, 4, and 5. And then I enter the corresponding data in line 2. I should have each set of data matched up. Okay, once I've done that, the next step says choose our plot settings. So we go to second, y equals, and this is our stat plot. We want to turn it on, so we hit enter, and make sure it's flashing on, hit enter, and we've got our scatter plot. So the next thing we do is we hit zoom, and we go down to zoom stat. We'll zoom in on our statistics, and there's our scatter plot. Okay, what kind of correlation do we have? It would appear that it is positive correlation. I can draw a line of best fit through here. So the next thing we want to do is create our equation. So the next thing, after we've described our correlation as positive, we can model our correlation and by performing what's known as the regression. So on your calculator, the first thing you want to do is make sure that your diagnostics are turned on. So you hit second, go down to catalog or hit 0, and you're going to scroll all the way down to the D's for diagnostic. And that's going to turn on our correlation coefficient. The correlation coefficient will tell us how good our line of best fit is, how close our equation is to the actual data. Come on. And there we go. So diagnostic on, we'll hit enter and run it, hit enter again, done. So now we go to stat, and we're going to go to calculate, and then go down to linear regression, linreg here. Hit enter again. X list is our L1, Y list is our L2, that's right. And we're going to calculate, and there's our equation. Y equals AX plus B. So A is our slope, B is our intercept. So our equation would be Y equals 1.36x plus 27.72. And the R squared and the R values are correlation coefficients. So we're looking for the R value being close to 1. If it's close to 1, it has strong positive correlation. Close to -1, strong negative correlation. If it's close to 0, the data would have relatively no correlation. So we can go back to our calculator. Since this is 0.988, that's pretty good, positive correlation. We can go in and enter our equation in our calculator. So you can either type it in, or we go to variables here, go down to statistics, and go over to equation, and regression equation is what we want. Hit enter, and it enters our equation for us. Notice I don't have to remember all those numbers and type them in. Then I go back to my graph, and I see my line of best fit being drawn in there. Okay, so that's how it's done on Graphing Calculator. It's a lot simpler than having to do it by hand. And you'll find once you get the hang of it, it's actually pretty simple. So the next thing we could do is we could use our calculator, hit the trace button, and click onto our equation. We can use that to make predictions, like when x is 3, how many, what was our variable sample? Sales in billions of dollars. There were about 31.8 billions of dollars sold in year 3, which would have been 2000. So we can trace on our graph to find out different values, or we can go to our table and look to see the different values that existed there. So after about 15 or 20 years, they're about $54.86 billion. Okay, or we can find out when did it reach $100 billion. We can go down until our y value is about 100 after 55 years. Okay, so we can use our data, our equation, to take a look at what's going on. All right, so the next problem we'll take a look at for men's clothing sales. Let's look at that from Desmos. So if we click on to Desmos here, I think I have the right, let me open the right example. Okay, so for this one, what I need to do is, first of all, I need to enter a table. And the way I do that on Desmos is I click Add Item and Table. And then I type in my data just like I did with the other example on the graphing calculator. So years since, I go 97, so 0, 1, 2, 3, 4, 5. And then I enter my values, 10.1 all the way down through 9.9. Once I have those, then I enter my regression equation. The way I do that, I'll show you how I do that. Enter expression, and then we hit y sub 1 so that the computer knows to use this y value. And in order to do that, I go down here to this button, and then I click 1, then I hit over, and then instead of the equal sign, we're going to use a squiggly. That shows that we're using a regression equation. And then just like our slope-intercept form, mx plus b, so mx sub 1, and then I hit over again, so I'm out of the sub, and then I hit plus b. And that will automatically create our regression line. And we can take a look at what we have. And it looks like our regression line is listed here, y equals negative 0.05x plus 10.5 if we round up. And if we look at our R values are negative, so it's got negative correlation. It's negative 0.257, which is close to 0. So we'd say this is probably not the best line of best fit. The data really doesn't have a whole lot of correlation. I can zoom in and see that. It has relatively no correlation, we would say. So it wouldn't be very trustworthy. But let's answer the questions that we have provided here. And let's take a look. So describe the correlation. We said it looks to be slightly negative. We got our equation. We drew the line of best fit on the calculator. What values of R does it tell you? And we mentioned that it's closer to 0, so it's probably relatively no correlation. Now, how could we use the best fitting line to predict future sales of men's clothing? We take a look back at our calculator, and well, we could drag. Here's the nice thing about Desmos is we can drag right along the line to trace it and say, well, after about 10 years, we'd be at about 10, what was our equation? Or $10 billion. So it seems that sales are diminishing. But that's about the same value that we had in our data up here. Kind of jumped around all over the place. And since our R value shows that this has relatively no correlation, we can't really trust our line of best fit to make predictions, make calculations. So unless our R value shows that we have good correlation, we need to be careful and can't use it to make predictions. All right, so we learned how to take a set of data and find out if that data has positive correlation or negative correlation, or if it doesn't really have correlation. And I showed you how to do this by hand and also on a graphing calculator and on a Desmos. So use that to help you plot the two sets of variables that you get in your practice problems and use that information to create equations and make predictions.